to have an open participation style for his presentation. So I would really encourage everyone to open up their cameras and raise their hands, open up their mics and ask questions. We're going to extend a little bit into the Q&A session for this as well. So don't feel as though you're holding anything up. Definitely come off your camera, definitely come off your microphone, put questions into the chat, and I'll let Dr. Joaquim say the rest.
Thank you, team. Can you see my slides?
Yes, you can.
Thank you so much. Thank you, Radhika and Hayan, for the invitation to speak today. And thank you, Ashley. You set the stage nicely for me to talk about the oceans and the changes that we are seeing in the oceans. So you know that 75% of our globe is covered by water, the oceans, the seas, and about 25% is land. And Ashley spoke about how, as we move into the future, disruptions to our climate, to our weather patterns will affect food on land, food production on land. And that is going to result in a lot of food insecurities all over the world. And so as climate changes, I anticipate that we will slowly be relying on the oceans to produce most of our food. So at the moment, we produce about 20% of the world's, the seas provide about 20% of the world's protein requirement. And I think as we move into the future, and as people start moving away from inland to coastal regions, as we see now for their job security, and that's happening all over the world, whether you go to China, you go to India, people are moving towards the coast. That's where all the jobs are available. So a lot of people will depend on the sea for their source of food. So today, I'll start this talk by transporting you to a region of the world where about 2/3 of the world's population is affected by this little ocean that is present here. So I'm going to talk about this little region over here that is called the Arabian Sea. And you can see the footprint of this, the real estate occupied by this little ocean is very small compared to, say, for instance, the Atlantic Ocean, if you see over here, or the Pacific Ocean. It's very, very small. One thing that I want you to note over here is that unlike the Atlantic Ocean or the Pacific Ocean, the Indian Ocean, of which the Arabian Sea is part of, this entire region is called the Indian Ocean, is landlocked. Okay, so it is landlocked to the north. And so unlike the Atlantic Ocean and the Pacific Ocean, there's no free exchange of water happening across from the tropical and temperate regions into the polar regions, especially the Arctic Ocean. Now, this is a map showing the world's population distribution. And you can see that this region, because it controls the rainfall patterns over this region, which is India, the Indian subcontinent, and most of Southeast Asia. And in this region, about 2/3 of the world's population resides. So any changes that happen in this ocean downstream of this region, and I'll talk about the monsoons in a little bit, has a huge impact on the food security in this region. So if there's a failure of the Indian monsoons, you will see that, that it affects crop production or agricultural production. And when that happens, it destabilizes the entire world. It has a huge ripple effect on the economy in many, many countries, especially those that are affected, but the rest of the world as well. So, and this region is really the gateway, the Arabian Sea is the gateway to the Middle East, where we get most of our oil from. So any insecurities over here, whether it's wars that arise out of food insecurities or water securities, can have a huge impact on the energy supply to the rest of the world. So this area is very, very important. And I'm often asked the question, you are working in a US lab, and why should you be working in the Arabian Sea, which is so disconnected from here, from the USA? And why should the US government be spending money in this region? But there's a reason for that. Any disruptions in this region has a huge impact on the rest of the world, on food security, energy security, and also stability in the region. So how many of you have heard about the monsoons? I would like to ask the audience this. And if someone can even post in the chat and tell me what monsoons mean. So because today I'm going to talk about the Arabian Sea and the Indian monsoon, okay? So anyone ready to answer online? If not, we can move forward. Tim, is there anyone who has responded?
People are saying in the chat that they do know what monsoons are. I'm waiting to see if anyone can tell me, because I'm not very well versed. If anyone can come on to the microphone even and tell us.
I live in Japan, so we like frequently experience monsoons, but they're typically like periods of very like high intensity, like rainfall and wind.
Yeah,
Yeah,
monsoons are a rainfall.
Fantastic. Yes, so this rainfall patterns, monsoons are actually winds, okay? And these winds that blow over the ocean is what drives the moisture from the sea to the land. And these monsoons are responsible for bringing in rainfall to many, many countries. The word monsoon comes from an Arabic term called mausam. And so they were the first to talk about the monsoons. And it is apt that these winds are called the monsoons, okay? So the Indian monsoon is very, very peculiar. It is the only monsoon that reverses the direction of the winds. And here what you're seeing on the right, which is the animation over here, is at some time of the year, you see the monsoons blowing from the southwest direction up northwards, okay? And during winter, you see the monsoons reverse their direction. You can see the winds coming from the landmass to the sea. So this is one thing that is very, very unique about the Arabian Sea monsoons, is that you have a seasonal reversal of these monsoonal winds. Okay. So these winds for an oceanographer like me is what drives the current systems in this region. So because of the way in which the winds blow in one direction or the other, they alter the circulation in this water. Okay, so when it's blowing from the southwest, you can see the water color. This is the sea surface temperature, and the blue color indicates colder waters. Okay, so this entire region during the southwest monsoon becomes cold. Okay. And during the northeast monsoon, you can see a little part of this portion becomes cold as well. But the Arabian Sea is a tropical ocean. It is warm throughout the year. But during these two periods, during the southwest monsoon and during the northeast monsoon, it becomes a little colder. And the reason why it becomes colder during the southwest monsoon or the summer monsoon is because of a process called upwelling. Okay, you can see these waters. The ocean circulation behaves in such a way that if the winds are blowing in this direction, the waters move at right angles to the wind direction. Okay, and this process is called Ekman pumping. So the Ekman pumping will pump away the water away from the coast, but at the same time, it brings the water from below to replace it. And this process is called upwelling. Okay, where you have colder waters coming up to the surface, and these waters are rich in nutrients. And in the same token, as I will show you in the next slide, is how these winds coming out from the mountain affect and make these waters cold. Okay. So this intensity of the winds is actually regulated by the pressure difference between the land and the sea. And this pressure difference is controlled between how hot the oceans are or how hot the land is. So during summer, you can see we have very little snow in the Himalayan Tibetan region, okay? And the Indian subcontinent becomes very, very hot during summer. And because it becomes very hot, it becomes a region of very, very low pressure. And the seas are slightly cooler. So the winds, they blow in this direction because of this pressure gradient from a high pressure region to a low pressure region. So, and as I said, as these winds blow in this direction, they cause a process known as upwelling along the coast of Somalia, Yemen, and Oman. And this area, what I'm showing you here below these arrows is the color that we see from the space. And these colors tell us how productive these waters are. So you can see during this period, you have a lot of phytoplankton in the water, and this phytoplankton gives rise to fisheries. And it's really important for fisheries. Now, contrast this with the winter. In the winter, you'll have a lot of snow in the Himalayan mountains. The Indian subcontinent is colder than the surrounding seas, okay? And because it is colder than the surrounding seas, this becomes a high pressure region, and the seas become a low pressure region. So the winds come out from the Himalayan Tibetan mountains, and they blow over the Indian subcontinent and eventually over the Arabian Sea. And these winds coming out from the mountains are really very, very cold. They're dry. And as they blow across the oceans, they take away the ocean's heat. And this heat removal makes the waters very cold, and they make them denser. And as they become denser, they sink down, and they cause what is a process called as convective mixing. I'll try and explain this better, because this is really the basis of the Indian monsoons, the summer monsoon and the winter monsoon. Okay? So in this area too, you see that there is an increase in chlorophyll that takes place. Okay? So because of a process called convective mixing. And this both upwelling and convective mixing give rise to these large blooms of phytoplankton. And these large blooms are largely made of organisms called diatoms. And if you go to the fish market during the summer monsoon or the winter monsoon in any of the countries around this region, you'll find that they are, you'll find mostly sardines and mackerels, which are the big pelagic foods that these diatoms support. Now, this is a time series map of air temperature anomalies over the Eurasian subcontinent. Now, this is over entire Europe as well as Asia. And you can see this data goes back from 1960 to 2018. Okay? But these are anomalies. So a zero measurement of anomaly will tell you there has been no temperature change over the past few years. Okay? And so if you look at the past, temperatures were very, very cold by at least half a degree in the past up to about 1998. We have had spikes from time to time, but this was short-lived spikes, okay? But since 1998 or so, the oceans have, the air over Eurasia has been rising, the temperatures of the air. And so we have seen since 1998, we are seeing an increase in air temperatures over the Eurasian continent. And this year in particular is very, very hot. Europe is hot. United States is hot. We are, our temperatures are about 3 degrees higher than normal. And that's why we are feeling this heat and humidity that we are experiencing now. But this has been going on since 1998, and it has continued. So we have not seen a decrease in temperatures like we've seen in the 60s to the 1990s. Right now, we are seeing a continuous increase in temperatures from year to year. And because of these temperature increases, so this is the snow cover extent over the Himalayan mountains, okay? And this is again, the area of the mountains that is covered with snow. So in the past, this is again anomalies from 1967 to the present day. You can see in the past, we used to have a lot more snow in the Himalayan mountains, okay? And since 1998, we have seen a consistent decrease in snow cover extent. So if I give you some, we have lost about 200,000 square kilometers of snow cover over the Himalayan mountains. And just to give you some perspective, this is roughly around 3 times the size of Texas that we have lost the snow cover over the Himalayan mountains. So this has been having a huge impact on the monsoons, and we see this manifest in the form of erratic rainfall. So every year since 1998, India has been experiencing this erratic rainfall. 2009, 2014, I'm just giving some example, 2015, 2018, this year too, in India, we have floods all over. In 2014, we had a river change its course, and you see that this was in a town called Patna in Bihar, in central India. The river came gushing through the main city and took away temples, and you can see some statues floating away. In 2015, this was in Kashmir, where you saw there was the cloudburst and it washed away some huge parts of the city. And this was in South India. And this year we are having these floods in New Delhi, where one of the rivers has started overflowing and it is threatening the lives of many, many people. But today I'm going to talk about what is happening in the sea, okay? So since 1997 to the present, okay, and I'm giving you data just from 3 different years. So this is the color of the ocean that we can see from space now, thanks to satellite technology. And the reds and the yellows and the greens that you see here are false colors, but they tell you how productive these waters are. So since 1997 onwards, the Arabian Sea is becoming more and more productive. So it is containing more and more phytoplankton. You would think that this is really, good for the environment. But what has been happening, there's so much of phytoplankton being formed now that most of it goes unconsumed by the higher trophic levels like zooplankton, and it sinks down. But in the process of sinking down, it is sucking out the oxygen from the system. And I told you earlier, the Indian Ocean is the only ocean that is not connected to the Arctic, okay? So because this landmass is locked by a landmass, there's no free exchange of this water. The water recirculates over here, and as we move into time, there's more and more oxygen being sucked out from the system. Okay, so this is happening during the southwest monsoon. So just to put it in perspective to you, so in the past we had more snow in the Himalayan mountains, okay? You had a colder landmass. The pressure difference between the land and the sea was weaker, and you had weaker southwest monsoons, okay? And when you have weaker southwest monsoons, you have weaker upwelling and less phytoplankton in the water. Okay. Now, one thing that I want to mention to you is that the Arabian Sea has a permanent oxygen minimum zone. Now, this oxygen minimum zone is like a dead zone. We have this in the Gulf of Mexico. We have this off the coast of Peru. And over the entire planet, these oxygen minimum zones are spreading because of the warming that is happening. Okay. But in the Arabian Sea, this oxygen minimum zone is spreading very, very rapidly. So, and the reason is because of this, okay? So we are seeing there's less snow in the Himalayan mountains. There's a stronger land-sea pressure gradient. We are getting stronger southwest monsoons, more rainfall in India. But in the sea, we are having stronger upwelling happening off the coast of Somalia, Oman, and Yemen. And you have more phytoplankton in the water. And I said, there's nobody to consume this phytoplankton. We should have seen more fish, but instead we are seeing that the oxygen minimum zone is expanding. So this higher productivity is contributing to the spread of hypoxia. And this is connected to the warming of Eurasia and the loss of snow in the Himalayan Tibetan mountain. Now I'm talking here about the southwest monsoon. Now, if you go to the winter monsoon, okay, I said that the winds come from the land to the sea during winter, okay? So you can see the winds coming from the land to the sea, they pass over the Himalayan mountains. They're colder and drier. And because they're colder and drier, they take away the heat from the surface of the ocean. Okay, this water becomes denser and it sinks down, okay? And as it sinks down, the water from beneath comes up to the surface and it fuels this phytoplankton because it contains more nutrients. So this was in the past. And this is what is happening now. We have less snow in the Himalayan mountains, as I showed you. The winds coming out from the mountains are warmer and more humid. And we have this weaker convective mixing. So what would you have expected? Less phytoplankton, okay? Okay, so we have got data that shows that the winds, the air is warmer now than ever before. The winds coming out warmer as well. And the humidity, the amount of moisture the winds contain is becoming more. So they're, instead of being dry, cold winds, they're warm, humid winds now. And this is affecting the circulation in the Arabian Sea. I won't go into details over here, but just to reiterate the fact that in the past it was like this, where we had colder and drier winds, stronger interconvective mixing, and more phytoplankton. And this is what we are having. We should see less phytoplankton. So this is pretty straightforward. Unfortunately, if you look at the chlorophyll concentrations, which is an indication of what we measure from space, if you measure this over the entire Arabian Sea, you can see that instead of going down as per this yellow line, okay, we are seeing that the chlorophyll is going up, and so much so that it has increased about threefold over this past from 1980 to 2018. So this results really surprised us as a biological oceanographer. And so if you look at this from space, you can see this how the Arabian Sea during the Northeast monsoon was very less productive in the 80s, and coming to the 2000 and all, it is becoming more and more productive. So these reds indicate that this area is becoming more and more productive. Of course, you see interannual variations, but just to give you an idea that this is roughly 3 times the size of the India that you see over here. It is becoming so productive. And we collaborated with Indian scientists to understand what was causing this increased productivity. As I said, we should have seen a decrease in productivity. We should have seen this yellow line, but instead we were seeing this increase in productivity that we see also in the satellite images for the winter. And what we saw, our ship occupied this area over here, and what we saw, the color of the oceans, which should have been blue, was green completely, okay? And you can see the satellite image which guided where our ship should go. And we used this to guide where we could sample, and we could see this area was green. And this is like turbid water that you would see along the coast. If you dropped a bucket in the water, it would be covered with this green mass that you see. And if you looked at this in a beaker, you could see that this thick blooms in the water. So if you tried to drop a net, it would look like a pea soup. So this really surprised us. And when we looked closely at the sample, this was the organism that was dominating the entire ecosystem. Just a single organism that has overtaken the entire ecosystem. It has destroyed the diatom blooms that we have come to expect. And instead, the diversity of diatom blooms that we used to experience in the past has been replaced by this single monoalgal kind of organism. Now, this organism has got peculiar features, and I'll try and show you. So this is organism, phytoplankton normally photosynthesize. Okay, so that's how they capture their food. They take carbon dioxide from the atmosphere and they produce organic matter. This organism can do not only photosynthesis with the help of these tiny little microorganisms that you see inside, but it can also capture other food. Okay, so it can capture all phytoplankton in the water. It can also capture zooplankton. So it's destroying everything in its path. It is a peculiar organism that has shown no mercy to this ecosystem. Now, it turns out that this tiny microorganisms that are living within it is an organism that is a green algae, which appeared on our planet about 1.2 billion years. Okay, so the first organisms that produced oxygen for us on our environment was cyanobacteria or blue-green algae. But this organism, this green algae, followed them about 1.2 billion years ago, and they also started producing oxygen. So they evolved, these organisms evolved in an environment that was low in oxygen and high in CO2. So I told you the oxygen minimum zone is expanding. Oxygen poor waters are also associated with higher CO2 waters. So this organism appears to be finding a perfect niche to spread and multiply. So as the Arabian Sea loses its oxygen, this organism is spreading. And I said that it eats everything. So it's eating up the diatoms. You can see it in their food vacuoles. Other zooplankton cannot consume it because it's slightly larger than normal. And it also has got this habit of eating zooplankton as well. So it not only feeds on phytoplankton, it eats what was supposed to be its major prey. So you can see this zooplankton eaten by this Noctiluca. So this organism is called Noctiluca. It's also known as sea sparkle. And sometimes if you go to the beach in Southeast Asia or in Oman, you can see the water changes blue. You can see like this bioluminescence on the surface. And the only organisms that can feed on this are jellyfish, and this organism is called salps. And here you can see the Noctiluca in their guts, okay? And you see them slightly being impacted by the accumulating in the guts of this organism. And this is what you see after a Noctiluca bloom. You'll see a lot of salps along the coastline. What I want to show you is the country that is most affected by this Noctiluca blooms is Oman. You can see almost the entire winter season from December onwards to February, you can see this Noctiluca blooms. They are green in color, sometimes they change to orange, okay, and golden yellow, but they're occupying the entire Arabian Sea. So you can see in 2023, this is from February of this past year, you can see Noctiluca blooms all over the Arabian Sea. And this is what it is causing to the food chain, okay? So Noctiluca is not giving rise to fish as we have come to expect. Instead, it's giving rise to the salps and jellyfish. And the only organisms eating these salps and jellyfish are squid, calamari, as well as turtles. So you can see this is along the coast of Oman. This is in the Straits of Hormuz. This is Oman over here, and it's the southern part of Oman along the coast. And you can see what fishermen are catching today is mostly this jellyfish, okay, instead of fish. And you can see these are the intake channels for many of the desalination plants. And this is a far away shot. But if you look at it very closely, you can see an engineer trying to clear this jellyfish from the channel over here. So these channels are completely blocked. They block these intake channels for the desalination plants, for the refineries, and for many of their coastal industries. So it's a threat to their energy security, it's a threat to their water security, and it also affects aquaculture farms and many of their fisheries also. So it affects food security as well in the sea. And I said this organism is spreading really rapidly. So this is a picture that was just sent to me earlier in March, and you can see that soon after Noctiluca blooms, this is what happens, dolphins dying along the coast. I could show you some more of lobsters also dying. So this is what the food chain was in the past. We would have phytoplankton mostly made up of diatoms, and then it would be grazed by zooplankton. We would have fish forming. So this is the classic food chain. And you would have detritus forming. You'd have few turtles feeding on this detrital material or sometimes on fish or calamari. But today the ecosystem has changed. Instead of phytoplankton, we are having mixotrophs, these organisms that can do both photosynthesis and they can feed on other stuff. So they're called mixoplankton. So they feed on phytoplankton, as I showed you, they feed on zooplankton. And instead of giving rise to fish, we're seeing jellyfish. And then we have a food chain that is completely altered. We are seeing more squid, and you're seeing more turtles over here in this region. So in Oman, they're seeing more landings of, instead of fish, they're seeing squid. And in the Middle East, squid is not a preferred food. So the prices of fish have gone up. And so it is affecting the availability of food locally as well. So what do we do with this information and how can we help? So we have been working very closely with this government of Oman to develop this forecasting system to predict the onset of these blooms. because if we can predict the onset of these blooms, we can tell their local managers, okay, you have a bloom coming, you need to start conserving water. Okay, or you can move your aquaculture farms from one place to the other, which will not be affected. So we have developed this real-time forecasting system, not only for ocean currents, but also for Noctula blooms. We also can forecast the weather conditions. And I'll give you some examples of what we've done. I won't go into details of this, but we take all the satellite imagery that we got. We have got this model over here, and people send us information from time to time. It comes into our system over here called DISCO, Decision and Information System for the Coastal Oceans, or for the coastal oceans of Oman in this case. And we fuse all this data and we serve this data to them to forecast harmful algal blooms, to forecast sea state. And this is how you would look at this information on the screen. So you can see the distribution of phytoplankton in the water. You can see the ocean currents. You can see the temperature of the oceans. And you can use this information actually to forecast the arrival of the blooms. And I'll give you some examples of how we do that.
Dr. Joaquim?
Sorry?
Just so you know, we have about 10 minutes left, and I just have a couple of questions, I think, from the chat that they maybe wanted to hear. Some of which have been answered, and some of which I think there was one by Senna.
Yeah.
Is there any evidence of ecosystems managing to successfully adapt to these climate change-induced changes? For example, the lack of phytoplankton or more phytoplankton, or are we past the point of no return? There were some questions about whether the green color organisms can do photosynthesis, and you explained they can do both eating and photosynthesis. And I think the next question is whether the organisms make the ocean animals and plants die due to lack of oxygen by taking the oxygen and modifying the food chain, or are there other ways that they can impact? So just those couple of questions, sorry.
Yes, these are fantastic questions. Okay, so they are not a preferred food for many organisms. So the only things that feed on them are salts and jellyfish. And as I showed you, it's altering the food chain. And instead of seeing fish now, we are seeing squid, turtles increase in this region. Now, they are also altering the amount of oxygen in the waters as well, because unlike plant that produce oxygen, these organisms, they produce more carbon dioxide than is necessary. So they are sucking out the oxygen from the system and they're depleting the oxygen even more. So as we move into the future, we'll see more and more of these organisms. And as far as, I think in 1998, we crossed the tipping point. The ocean ecosystem in the Arabian Sea has shifted, and we have reached a point of no return over here. So we have to learn to adapt to how this changes. And one way we can adapt to these changes is try and develop some kind of systems where we can actually start looking at how we can use the information. Now, in this case, you can see that we are using the ocean currents over here. So if we see a bloom in the satellite image, say around this time, okay, the people in Oman can drop these particles, these artificial particles, assuming that this is where the bloom is formed. And you can see the time of arrival of this bloom that is formed first offshore. You can tell at what time it will come to the shore. So based on this particle distribution, you can do that, okay? So this gives the managers some time to prepare for this eventuality where they have large jellyfish blooms, which clogs their intake channels for this desalination plants and also for their refineries. So they can take some action. And now in Oman, they're building large reservoirs that are underground and also exposed to the air. So they want to conserve as much water as they can. So this is one tool. These blooms also result in fish mortality. And this is one that occurred after Noctula Bloom. You can see all the sardines in the waters died. And they thought that the bloom was toxic, but actually it was due to something known as so I said that we have a lot of upwelling that happens here. And when upwelling happens along this coast, there's a lot of oxygen poor water that comes up from the deep up to the surface. So with the help of our model, we could tell that this was not due to a toxic algal bloom, but this was low oxygen water that was being pinched away from the coast. It was taken by the currents, and you can see the currents taking this water right into the Sea of Oman and dumping it here along the coast of Oman. And it was dumping it into these bays where there was no oxygen in the water, and you could see there was a lot of sardines that were killed. Because this model is coupled to the atmosphere also, we can predict cyclones with this model also. So as you know, the Arabian Sea is more prone to cyclones now. So our model can predict the paths of the cyclone. In this case, this was in 2019, there was a cyclone that formed off the coast of India. There was back-to-back cyclones actually. There was one that was heading towards, both were heading towards Oman, but we had predicted that the first one that was heading right for this part of Oman, Muscat and all, that it would change its course midway and head towards Yemen. And if you see what we had predicted about 7 days in advance, it showed that this cyclone changed its path and it headed south towards Yemen and Somalia. And the other one that was heading towards Oman, soon after that, instead of going towards Oman, it hit the coast of India. So we have developed these tools for them to help them manage their infrastructure, their water needs, their food needs. And so we are hoping that we are helping in some way to avoid this problem. So I'm going to end here. This is how, as I said, that the amount of turtles along the coast of Oman has increased. And this is work done by a student where she took data from turtles that were tagged, and she used this information to show how these turtles migrate from an island here in the Indian Ocean towards the coast of Oman. So all of them are moving to this region in search of food, jellyfish, as well as salps and squid. Now, as I said, this thing is spreading all over, and this is what happened in India in 2018. Okay. Just so that you know that this is not a problem that is unique to Oman, but to the India as well. So you can see this green algae floating. This is Noctula Bloom again. And this is what it is causing in India. You have massive fish mortality. And you can see this is also causing sardines, to come along the coast. So people think that they're having a better harvest of sardines and mackerels, but what is happening is that the oxygen minimum zone is spreading. It is coming up to the surface and it's constricting their habitat. So all the sardines will be coming to the surface, but the waves, they wash them to the shore. And this is what people are collecting. This is in my hometown in Goa, India. Yeah. And this is my last slide. These blooms can be seen from space, and you can see they look pretty from space, but they're causing huge damage to the environment. And so this is a quote from Brian Bigelow, who was the founder of the largest oceanographic institute in the United States, and it was the first oceanographic institute. He presented this to Congress in the 60s, and he was trying to demand some money for oceanographic research, saying that this is an interconnected world where our oceans, our atmosphere, and our food are all connected. And we need to study this in order to predict future changes. Okay, thank you.
Thank you so
I'm
much.
happy to take some questions, okay?
Yeah, so there's one in the chat that I saw. How can we prevent the spread of these organisms which causes damage to animals and plants, which in other words translates to, how is your job going to address these issues and adapt, like you said, because we are past the point of no return. And then there are some other questions about the other areas of the world where this happens, like the Gulf of Mexico, Tampa Bay, and any place that has a low oxygen, high CO2 condition. Are they at the same risk for these organisms?
Yeah, so one of the closest water bodies to us here in New York is Long Island Sound, which experiences oxygen depletion during the months of summer. So the oxygen concentrations at depth decrease very much. And that is a combination of the rainfall that takes away a lot of fertilizers from the land, and you have something known as combined sewer outflows. Sometimes these sewage treatment plants, they overflow, and all the organic matter comes into Long Island Sound. And when that happens, there's a lot of oxygen lost in the system because bacteria start impacting, it gets attracted to the organic material and it sucks out the oxygen. So you have a rapid loss of oxygen. So what are the solutions for this? And it's a really difficult problem. We have done some experiments in the lab with Noctula, and we are the only lab in the world that has this organism in culture. So last year, we worked with some high school students, and believe me, a high school student found a substrate that can stop Noctula from growing. Now, the challenge for us moving forward is how do we apply this to the natural world? As I said, that the size of the bloom is almost about 3 times the size of India, okay, or roughly 3 times the size of, 8 times the size of Japan, or 2 times the size of Texas. So it's a huge challenge to use that substrate over this entire region. So just like you have forest fires, we are thinking that, when a forest fire starts, it starts in a small place. So if you can douse the fire at the point of its origin, you can stop this fire from spreading. And so we know that this organism forms off the coast of Oman and then slowly spreads as the season progresses to the rest of the Arabian Sea, and it comes down to India, Kenya, Tanzania. So if we can stop the organisms in the Sea of Oman, we think that we can solve the problem. But this is still challenging. And just yesterday, day before yesterday, we launched a project in Morningside Park in New York City, which is being afflicted by another kind of harmful algal bloom. There's the Morningside Park has got a small pond, and for the past 5 or 6 years, they have been having this algal bloom problem that makes the water completely green, and it's also a toxic algae. So that Morningside Park, we think, is really a nice test bed to test some of the techniques that we develop in the lab. So using that as a test bed, we'll be working with some engineers to try and solve the problem in the small water body, take it to Central Park where you have a larger water body, and eventually take it to the oceans where we can solve a larger problem.